So can you do quickly recap whatever we have studied in this chapter?
Yeah, sir, I'll just do. So, we learned about density. What is the formula of density? So, the formula of density is mass per volume. Then we एक मिनट सर मैंने कहाँ लिखा था हाँ ये रहा then what is the SI unit of density which is kg by meter cube CG's unit of density is gram centimeter cube so
How will you convert 1 gram centimeter cube into kg per meter cube?
we'll multiply into 1000.
So if you multiply this by 1000, you will get the value in kg per meter cube. Okay.
Yeah, sir.
Okay, so 1 kg is equal to how much gram?
1000 grams.
Okay. 1 meter cube is equal to how much liter?
Sir, 1000 decameter.
Deca nahi beta, deci.
Okay, sir, decimeter.
So 1000 decimeter cube, not decimeter, decimeter cube.
Okay, sir.
Okay, one. So remember this. So when you talk about kilometer, 1 kilometer is 1000 meter.
1000 meter.
Okay. 1 decameter is equal
to 10 centimeters.
10 meter.
Okay, 10 meters.
1 meter is equal to 10 decimeter. 1 decimeter, where 1 decimeter is equal to 10 centimeter, where 1 meter is equal to 100 centimeter. All this you remember. So here, when I'm asking you 1 meter cube, that is equal to 1000. That is equal to 1000 decimeter cube. 1 decimeter cube is equal to 1 liter. So if I ask you, then 1 meter cube is equal to 1000 liter. 1 meter cube is equal to 1000 liter. Okay, 1 liter is equal to 1000 centimeter cube. 1 centimeter cube is equal to 1 milliliter. So remember, 1 meter cube is equal to 10 to the power 6 centimeter cube.
Okay, sir.
Remember this. Okay, so this you understood. We were talking about the formula of density. So the formula of density is
mass by volume.
The formula of density is mass by volume. Okay, what is mass?
So mass, you can define mass by telling that mass is the how do you define it? I forgot. No, yeah, mass is a quantity of matter which is contained in the body.
That is mass. What is the volume?
A volume can be defined as volume.
Volume is you studied all this in 7th standard. Volume is the space occupied by an object.
A volume is the space occupied by
an object, which we measure in 3 dimensions.
Okay, sir.
So area is the space occupied, which we measure in 2 dimensions.
Okay, sir.
So volume we measure in 3 dimensions. So what is the SI unit of mass?
kg.
What is the SI unit of volume?
Meter cube.
Meter cube. Okay. So what is the CGS unit of mass?
Gram centimeter.
CGS unit of
it's gram, sir.
Gram. Volume is centimeter cube. Okay.
Centimeter cube.
So how mass is different from the weight?
So should I basically differentiate between it?
Yeah.
So the mass is something which has
mobile in silent mode. Yeah.
Yes, sir.
Put mobile in silent mode.
Mobile is in silent mode only.
Okay. Some sound is coming.
Okay. Okay. Sir, should I start doing it?
Yeah.
So you can define by telling that basically mass is a property of matter, and it is no, I can't. So maybe I can tell. Can I start again? Mass is a scalar quantity where weight is a vector quantity. Mass can be the unit of mass is kilograms, whereas in weight the unit of weight is weight or Newton. So mass can never be zero, but weight can be zero based on the gravity acting upon it. So and mass is measured using ordinary beam balance, or where sorry yeah when weight is measured using spring balance.
Okay, what is SI unit of weight?
A Newton.
Newton. What is weight?
Sir, weight you can define it as weight. Weight is the force of attraction where the earth pulls.
So if you go to Jupiter, will your mass will change or will your weight will change?
The mass will change.
Okay, mass will change, weight will not change.
No, weight will also change. Sorry.
Both
the weight will also. Yeah, both is
mass will also change, weight will also change. That is 100% wrong answer. Your mass will not change, your weight can change because your weight depends upon the force of gravity. Mass does not depend on anything. So mass is not going to change. Your weight is going to change.
Okay, sir.
Please remember, you studied all this in 7th standard physics. You all forget whatever you studied last year, everything you forget only. So now talking about density, the formula of density is mass by volume. When we talk about density formula, that is mass by volume. What is density? So density of an object we can define as the mass of an object in a given volume. Different object around have different density. Okay, so density help us to understand how compact the mass of the substance is. So to understand how compact the mass of the substance is, we use density. Okay, density represent how closely items or molecules are arranged in a material. So with this, you can understand that the density of solid will be the maximum, followed by liquid, followed by gas. Because when you talk about solid, the intermolecular force or attraction is very high. The molecules are arranged in proper order, and because of which they have very less intermolecular space. The molecule only vibrate along their mean position. You know the SI unit of density is kg by meter cube. Its CGS unit would be gram by centimeter cube. This conversion already we discussed. Okay, so in general perception, we says that if you heat any substance, automatically the molecules will get free. If the molecules will get free, the volume will increase because more heat you transfer, more kinetic energy, the molecules will get more vibration. They will try to make, and in case if you gave them too much energy, then they may change their state also. But at least the volume will increase. So if the volume will increase, definitely on heating any substance, the density will decrease. So that is the general perception of about density will decrease while increasing the temperature, and density will increase while decreasing the temperature. The only exception is the water, where if you heat the water from 0 to 4 degrees Celsius, its density actually increase, its volume actually decrease, and the maximum density what the water will have, that would be at 4 degrees Celsius, and that would be equal to 1000 kg per meter cube or 1 gram per centimeter cube. That is the maximum density of water.
Yes, sir.
So you can remember this. Now, measuring density of solid. So it is how we measure the density of solid, Tanish?
Sir, we have a few vessels which we use.
Can you mention the name of the vessels? I think you forgot.
No, sir. I think it is a density bottle.
Density bottle we use for liquid.
Liquid, no?
We not use for liquid, solid.
Sir, I'm not sure.
We have two instrument. We have measuring cylinder and we have Eureka cane. So we have measuring cylinder, we have Eureka cane. So by measuring cylinder, by Eureka cane, we can measure the density of the solid. So how you measure the density of the solid? So solid can be of two types. When we talk about solid, solid can be
regular and irregular.
Yeah. So if we are trying to measure the density of a solid, if we are trying to measure the density of solid, if we are working on it measurement, so please understand as such, there's no direct formula or there's no direct mechanism to measure the density. Density you can only measure by measuring mass and volume separately and dividing them. Mass you can easily measure. How you measure the mass? So you can measure the mass very easily by using beam balance. You can use beam balance or physical balance. So you can take any solid, either it's regular or irregular. So you can use beam balance or you can use physical balance to measure its mass. Okay, now the volume of finding volume of a regular solid is not a big task. So you can find the volume of a regular solid very easily by following the formulas of area and volumes what you studied till now. If the solid is a regular solid, it can be cuboid. If the solid is a regular solid, then it can be cuboid. It can be cube. The regular solid, if it can be cylinder. Okay, it can be sphere. So different forms of regular solids are there. So it can be cuboid, cube, cylinder, cube, or it can be what? So it can be cone. So depends which type, pyramid, whatever. So we know the formula of volume of cuboid, that is length into breadth into height. Cube volume is side cube. Then cylinder volume would be pi r square h. Sphere volume would be 4 by 3 pi r cube. Okay. Then cone volume is 1 by 3 pi r square h. So if we have a regular solid, we can easily find their volume by using the mathematical formulas what we have studied in the chapter area and volume. Okay, so this formula will help us to find the volume of, and we can easily calculate the mass by using a physical balance or beam balance. So simply if we divide the volume from the mass, we'll get what? We'll get the density of the regular solid. So that is very easy process to be done. While if we have an irregular solid, now for irregular solid, mass again you can determine by physical balance or beam balance. Now the question arises, how we can measure the volume of the irregular solid. Mass we can easily determine. So the mass, it doesn't matter it's a regular solid or irregular solid. Its mass we can easily determine by physical balance or beam balance or physical balance or beam balance. Now how to determine so determine volume of irregular solid. To determine the volume of a irregular solid, what we use the concept of, we use the displacement theory. We take the help of displacement theory. Using a graph paper. We use the displacement theory of water. We use the concept of Archimedes principle. We use the concept of Archimedes principle or the theory of buoyancy as discussed by Archimedes, Greek philosopher and mathematician. So what Archimedes principle basically talked about, Archimedes principle talked about that the volume of the water displaced by any liquid, when you put solid into that volume of water is equal to the volume of the solid which is being put into the liquid. So that concept we are using here to find the volume of the irregular solid. So we use like instruments like measuring cylinder, or we use Eureka cane. So when we talk about measuring cylinder, so what we can do, we can pour water into this measuring cylinder till certain height. Okay, and then what we do, we'll dip a stone into this cylinder containing water uh, through the help of any thread. You will tie the stone and then you'll dip that stone into the measuring cylinder. So automatically when the stone will enter into the liquid, automatically the level of the water will increase. So the difference in the volume of water, what you are observing before and after, will give you the volume of the irregular solid. The same thing you can do with the Eureka cane. So Eureka, this is what how Eureka cane is all about. The openings, what Eureka cane we have, the opening of the Eureka cane we called as a spout. So you fill the water till the exact top level, till the water has reached the spout, and you observe, you pour water into the Eureka cane, and you wait till no more water is going out from the spout. Okay, and then next to the Eureka cane, you put one
beaker. Have a measuring cylinder.
You put measuring cylinder or you put beaker, and then on this you dip a stone. You dip a stone or you dip any irregular solid. The moment if you dip a irregular solid into this, the automatically the level of the water will increase, and the level of water whatever will increase, that cannot stay into this beaker, that automatically start coming out. Okay, and then it will collected. You will collect that water next to that with a measuring cylinder, and the volume of water which came out will give you the volume of the irregular solid which you have dipped into the liquid, and that gives us the volume. That will give you the volume of the irregular solid. Once you get the volume of the irregular solid, once you have the mass of the irregular solid, so by dividing the volume from the mass, you get the density of the irregular solid. Any doubt?
No, sir.
So you can read this: a measuring cylinder used in laboratory, which is cylindrical in shape,
marketing.
The volume of the liquid. To measure the volume of irregular solid, the water is poured into the cylinder, and then its initial level is noted, and then through tie, then we can tie the solid with a thread. Then the irregular solid is being immersed into the cylinder containing water, and then the final reading of measuring cylinder is taken. The difference in the volume of water is the volume of the irregular solid. Any density can be calculated by the formula, that is mass divided volume, where mass is calculated by beam balance or any physical balance. The Eureka cane, if we talk about Eureka cane is a container with spout near its top. Spout means opening. That opening we call a spout. It is based on Archimedes principle that the amount of water displaced by the object is equal to its volume, which I just now told you. Now what we'll do here,
Sir, I had a doubt.
Yeah, tell me.
Sir, is this cans made up of a glass or a plastic?
It can be either glass or either plastic. So if you use glass, then it would be easy to locate the values. It's always good we use glass, because with glass you can see the amount of water you pour to measure the volume. So you need glass because glass are transparent. If you use plastic, then it would be difficult to observe them.
Yes, sir.
Because ultimately you have to measure the volume of the liquid. So if you want to measure the volume of the liquid, for that you need substance which should be transparent in it. Then only you can see the volume. So now when we talk about Eureka cane is a container which spout it near its top. It's based on Archimedes principle that the amount of water displaced by any object is equal to its volume. So this can be filled with water up to the maximum at level, and then the object is placed into that. The solid object displaces some water which is collected in a graduated measuring cylinder. So with that you can say that the volume of solid is equal to volume of water which is forced through the spout, and then ultimately it will give you how to measure the density of an irregular solid. Now we'll talk about measuring density of a liquid. So how we can work on liquid part, that we'll talk about. So normally if we want to measure the density of a liquid. So this is the logic what we follow. This is the formula what we work on to measure the density of a liquid, that is M2.
So 1 second, I'll just make a note.
Yeah.
Density of a liquid is measured is equal to M2 minus M1 by volume. Okay, sir.
So if we want to measure the density of a liquid, then you can easily understand finding the volume of a liquid is not a big task. You can pour the liquid in the measuring cylinder and you can simply observe the volume. I hope you understand it. Finding volume is very easy thing for liquid. You pour the liquid into the measuring cylinder and note down the volume. So your volume part is done. Now, how will you measure the mass of the liquid? So what we'll do to measure the mass of the liquid? So we'll take a measuring cylinder and we put some distilled water into that. We'll clean that properly. If required, we'll put vacuum cleaner and we make sure that it totally dried down. And once it totally dried down, then we can measure the mass of the measuring cylinder. Let the mass of the measuring cylinder is M1. Okay, then what you do, then on that measuring cylinder, you pour liquid. Then on the measuring cylinder, you pour liquid. And because you pour liquid into the measuring cylinder till certain volume, till certain height, with that you get the volume of the liquid very easily. Once you've done that work, then again you measure its mass. Now whatever mass you'll get of the measuring cylinder,
that's your M1.
That definitely should be more than M1 because M1 was the mass of the empty measuring cylinder. So M1 was the mass of the empty measuring.
Sir, I had a doubt.
Yeah, ask me.
So yeah, basically, example, if you take a bottle without water filled, and when you measure it, you have some amount. Example, you can tell the volume is 10 grams, but when you fill water and then
volume
measure
cannot be gram.
Sorry. So when you when you have an empty bottle and when you weigh it will be around some x kgs. So that will be your M1. When you fill the water and then measure it, that will be your M2, right?
Correct. So
then if you have to find, it will be M2 minus M1 by volume.
Yeah, that is your density.
Yeah, sir.
M2 minus M1 by volume is your density. So here the mass of the liquid would be M2 minus M1. Because once you measure the mass of the empty measuring cylinder, if that was M1, now if you measure the mass, definitely it would be more than M1. That would be equal to the mass of the measuring cylinder, empty measuring cylinder, plus the mass of the liquid. That is equal to M2. So what is the mass of the liquid? M2 minus M1.
Yeah.
So once you understood that is M2 minus M1, you can follow the formula. The density of the liquid is M2 minus M1 by volume. So with that, you will get the density of the liquid. Okay. So to measure the density of the liquid, we also use density bottle also. So we also use a density bottle to measure the volume of the liquid. We can spend some time discussing about that. That is given in your book. So we spend some time. So irregular, all that we measured. So now you can see to determine the density of the liquid, say milk, oil, etc. Its mass is measured by common beam balance and its volume V is measured by the measuring cylinder. Okay, then the density is calculated by this formula. So here they are given you how you can determine the density of a milk. So you take a beaker, measure the mass of the empty beaker using the common beam balance. Let that mass is M1 gram. Now take a measuring cylinder, okay, and pour some milk into that, say certain level. Suppose that level is 50 ml. So you got the volume of milk as 50 ml or 50 centimeter cube, because already I told you 1 milliliter is equal to 1 centimeter cube. Then transfer the milk of what you have, this 50 ml milk you got, which you measured with a measuring cylinder. Then you transfer this milk into empty beaker and measure it mass again. Okay, so that then you can measure mass again. Let that mass is M2. So from this, you can find the mass of milk, which is M2 minus M1. So once you find the mass of milk, you know the volume of milk already. You divide
And
that,
you have to divide by the volume.
and then you will get the density of the volume. Now, normally in laboratory or in physics instrument experiment, we use density bottle to measure the volume of a liquid. To work on the density calculation of a liquid, we use density bottle. What is density bottle? You can see this is a density bottle. This is what we use for measuring the density of a liquid. So what we do with density bottle? So a density bottle is basically, it is specially designed bottle which is used to determine the density of liquid. You can understand. It is a small glass bottle having glass topper at its neck. So you can see at the top you have
you have a glass topper there.
You can see a glass topper at its neck. Okay. So then the bottle can store a fixed volume of liquid. So whenever you buy this density bottle, you have density bottle of different volumes. Either it can be 25 ml density bottle, or it can be 50 ml density bottle. Okay, they are fixed with a stopper at its neck. At the top, they have a stopper, and this stopper has a narrow hole through it. So at the top, it's fixed with a stopper having very small space. Okay, so when the bottle is filled with the liquid and the stopper is inserted, so first you fill that bottle with the liquid and you put the stopper so that no more disturbance can happen, or the purity of the liquid should not be impacted. Then the excess liquid rises through the hole and drain out. So because, see, understand, so when you use this density bottle, they are of different volume. So you start pouring the liquid into the density bottle. Okay. And then what you do, you put a stopper at the top. So the moment you put a stopper at the top, then it cannot carry beyond a certain limit. The limit was mentioned, which was mentioned in the density bottle, maybe 25 ml or 50 ml. Whatever would be the excess water, definitely it will go out from the beaker. And then with that, you can always say that the bottle always contain the same volume of liquid each time when it is filled. So depend upon what kind of density bottle you are using. So since the density of water is 1 gram per centimeter cube, this is what we assume the density of water. Although this density we measured at 4 degrees Celsius, because water is having maximum density at 4 degrees Celsius. Here, for general perception, for calculation of relative density everywhere, we consider the density of water to be 1 gram per centimeter cube. Then for us, once we know that density of water is 1 gram per centimeter cube, then we can simply figure out if the density of water is 1 gram per centimeter cube. So automatically you can say that the mass of water will be equal to the volume of the water. So if you are having 50 ml density bottle, in that 50 ml density bottle, if you are putting 50 ml water, automatically the mass of that water would be 50 gram. You can easily understand. So because density we consider as 1. So nowadays it is not named. Nowadays it is named as specific density, specific gravity bottle also. The another name of density bottle is also specific gravity bottle also. You can remember. Okay, that you can remember. So then how will we find the density of liquid using the density bottle? To determine the density of liquid using the density bottle, we have to measure the mass of the liquid. Okay, so how will you measure the mass of liquid? You know that you take a measuring cylinder. Okay, you clean it properly, you measure its mass. Suppose that was M1. Now you pour liquid into that and again measured mass. Suppose that is M2. So M2 minus M1 would be the mass of the liquid. So by that way, you can measure the mass of the liquid. So once you're done with the measurement of mass of the liquid, okay, so then what we can do, we'll work on the density calculation. So for that, this activity is given to determine the density of a liquid using a density bottle. So first, wash the bottle and dry it. Okay, make sure that no impurities are present. Clean it properly with distilled water. Then measure the mass of the empty bottle using the beam balance. Suppose that is M1. Remove the stopper of the bottle, fill it with water, replace the stopper, wipe the outside of the bottle dry, make sure it is dry, then you can clean the stopper, measured mass again, let the mass is M2. Okay, then empty the bottle and dry it. Now fill the bottle with the given liquid, replace the stopper, wipe the outside of the bottle dry, measured mass again, suppose this is M3. Now calculate the mass of water. So what would be the mass of water? That would be M2 minus M1. Can you understand this?
Yes, sir.
The mass of the water would be M2 minus M1. M1 was the mass of empty beaker. Okay, and when you pour the water into that, and then when you calculated the mass, let that mass was M2. So now the mass of water is M2 minus M1. The mass of liquid would be M3 minus M1. So once you got that, and once you know that, if you are keeping or if you're using the same volume of liquid and same volume of water, then you can easily say that the density of liquid is equal to mass of liquid by the mass of water. You can easily say that part. You can very well say that the density of the liquid, when you say the density of the liquid, that density of the liquid would be M3 minus M1 divided by M2 minus M1. You can easily use that formula, because assuming if you are assuming that you are using the same volume of liquid and the same volume of water, you can find the mass of water as M2 minus M1. You can find the mass of liquid as M3 minus M1. And then if you individually calculating, then density of liquid would be the mass of liquid, which is M3 minus M1 divided by the volume of liquid. So volume of the liquid, when we talk about volume of the liquid, that volume of liquid is equal to what? That volume of liquid is equal to that volume of liquid, because liquid and water, you're carrying the same volume. I hope you're understanding. Liquid and the water, you're using the same volume. You know that the density of water is 1 gram per centimeter cube. I hope you're understanding, because we consider the density of water as 1 gram per centimeter cube. So density formula is mass by volume. So density formula is mass by volume. Density formula is mass by volume. If your density is water, in case of water, your density is 1. So if you say mass by volume, so in case of water, the mass of water is equal to the volume of water. Okay, now if we take equal volume, if we take equal volume of liquid, so if we take equal volume of liquid and equal volume with the equal volume of water, if we take equal volume of liquid and equal volume of water, if we take equal volume of liquid.
Sir, I wasn't able to hear you for the past 2 minutes.
No problem, you just pay attention. So if I take equal volume liquid and equal volume of water, so automatically you can say this, that the mass of water, which is equal to the volume of water, which is equal to the volume of water, which is equal to the volume of liquid. You know that the density of water is, we assume that to be 1 gram per centimeter cube, correct, right?
Yes, sir.
So we say that density of water is as 1 gram per centimeter cube. So if I work on the density calculation of water, so I can say that the mass of water is equal to the volume of water.
Yes, sir.
So once we understood that part, and if assume that because we are using a density bottle having a specific volume, and you are calculating the mass of water, you are calculating the mass of any liquid by using density bottle only, it means both you are keeping same volume. So the volume of water and the volume of liquid are same. And you know that the volume of water is equal to the mass of water. So I can say that all are equivalent. So if I talk about the density of liquid, if I talk about the density of the liquid, the density of liquid is the mass of liquid, density of liquid is the mass of liquid divided by the volume of liquid. So density of liquid is equal to the mass of liquid divided by the volume of liquid. So mass of liquid is nothing but it is M3 minus M1, and volume of liquid is equal to the mass of water. So I can say that is equal to M2 minus M1. So I can say that density of liquid, I can say that the density of liquid I can calculate by this formula. That will be equal to M3 minus M1 divided by M2 minus M1. This formula, with this formula, we can easily measure the density of a liquid.
Okay.
So once we understood this part, so then you should know the next concept. This is what we call as a relative density. So this concept, so when we talk about liquid, when we are talking about liquid, so the ratio which talks about the density of a liquid with respect of its density with respect to the water, this is we called a term, we use a term in physics, we call this as a relative density. So the relative density of a substance is defined as the ratio of the density of the substance to the density of water. So this you can remember. So if the density of iron is 7 gram per centimeter cube, that shows that iron will never float on the water. Iron will always sink down because the density of iron is more than the density of water. If anything which can float on the water, its density should be less than the water density. Like ice, if you calculate the relative density of ice, it is around 0.9. That's why you see iceberg floating on the water, floating on the sea water. So for any substance to float on the water along with the principle of Archimedes, what you know, you should also need to know the relative density of the substance which want to float on the water. For the ship, when the ship's construction
Yes,
are being done, for the ship construction, the calculation of relative density to make sure, they want to make sure that the relative density of the ship should be less than 1 gram per centimeter cube. Because for the ship, metals are being used, and metals relative density are definitely more than 1 gram per centimeter cube. So the ships at the bottom, the lot of hollow spaces are being given, okay, for the air to pass on or to reduce the specific density altogether or the specific gravity altogether of the ship below the or equivalent to the 1 gram per centimeter cube. Then will you ship can float on the water. Otherwise, if there would be a problem of running a ship over the sea water. So that problem is very big problem which the engineers face whenever they talk about construction of ships. So relative density, basically it talks about the density of the substance with respect to the density of water. Can you understand this?
Yes, sir. So it will take a little time, but once I listen to the recordings, no, I'll able to understand more.
Mm-hmm. So you know that whenever we measure density, so density of a substance is the mass of 1 centimeter cube of that substance. Okay, what is density? So density, when we talk about it, is the mass of 1 centimeter cube of the substance, because density is after all mass by volume. So if you make volume 1 centimeter cube, so the mass for that 1 centimeter cube of the substance ultimately talks about the density. Here the mass will be equal to density. So the mass of 1 centimeter cube of substance is basically called as its density. So here when we talk about relative density, so when we talk about a relative density of a substance, whenever I'm talking about relative density, if I'm talking about relative density, if I'm talking about a relative density of any substance, maybe any liquid or any substance, that is nothing but it is the density of the liquid. It is the density of the liquid divided by the density of water. Divided by the density of water. So what you can take under density of liquid, you can say that this is equal to the mass of the liquid. This is equal to the mass of liquid
Density of liquid
divided by
and
the
mass of
volume
liquid.
of the liquid. Okay. Then how will you find the density of the water? Density of the water is the mass of water, okay, divided by the volume of water. So imagine if you take equal volume of liquid and water, so you can easily say that a relative density of any liquid, relative density of any liquid, that is equal to mass of liquid, that is equal to mass of a liquid divided by the mass of water, that we called as a mass of the water. So that gives you the formula of relative density of the liquid. So that is equal to mass of liquid divided by the mass of the water. So that gives you the formula. So the same thing is written. So mass of any volume of the substance divided by the mass of the same volume of water. That is what is written. Relative density, the same thing I've written. So relative density of any substance, that is equal to mass of any volume of the substance. Mass of any volume of the substance divided by the mass of same volume of water. That's why the volume factor will get cancelled. So thus we can say that relative density of the substance can also be defined as the ratio of the mass of any volume of substance to the mass of equal volume of water. Is this clear?
Yes, sir. Sir, I may request if you can just send me the recording as soon as possible because मुझे थोड़ा relative density के बारे में थोड़ा समझ में नहीं आया ठीक से.
See, what is relative density? Relative density is very simple. कोई भी substance का density, if you divide by the density of water, you get relative density. Simple. That we call a relative density. When we measure the density of water for mathematical calculation, we'll take, if we can, many times we consider the density of water as 1 gram per centimeter cube at 4 degrees Celsius. So because that is the maximum density of water, so we assume that as 1 gram per centimeter cube. Okay, you can remember this. What is relative density? Relative density basically means कोई भी substance, कोई भी liquid का density with respect to the density of water. अब density का formula क्या होता है? What is density of liquid?
Density of liquid and
that is
volume
equal
of
to mass of the liquid divided by volume of liquid. What is density of water? Mass of water divided by the volume of water. If you take equal volume, imagine if you take equal volume, imagine if you take equal volume of liquid and water. Agar if you take equal volume of liquid and water, then automatically volume तो कट जाएगा. तो दोनों का volume तो same लिया आपने.
Yes, sir.
So ultimately, you'll get this formula that relative density of liquid is equal to mass of any substance divided by the mass of same volume of the liquid.
Okay, sir.
That we called as a relative density.
ठीक है सर, मैं भी एक बार पढ़ लूंगा तो मुझे भी I'll understand more.
Yeah, so this we called as a relative density. So this is what I wrote. This is a formula of relative density of any substance by the density of water. If you take equal volume substance and water, then two volume factor will get cancelled. So the relative density would be, when we talk about relative density, it would be mass of the substance divided by the mass of the water. That is what we call as relative density. In other words, the relative density of substance is the ratio of any volume of the substance to the mass of same volume of water at 4 degrees Celsius. This is how we define relative density. So it is a ratio of mass of any volume of substance to the mass of the same volume of water at 4 degrees Celsius. So relative density, when we talk about relative density, it is a pure number. It does not have any unit. And you know that relative density of water is 1 gram per centimeter cube that we consider. Okay, so when we talk about the calculation of relative density, we calculate by using density bottle. You know that very well. So वही चीज को explain किया. It is small glass bottle with a stopper with fine capillary tube. It has a fixed capacity. Whenever you take relative density bottle or density bottle, it you use for a definite volume which is marked on the bottle. How much is the volume? How much is the capacity that is marked on the bottle? So when the bottle is completely filled with the liquid, it means now the volume of the liquid is equal to the mark of the bottle which is given. And then when you put stopper into that, any extra water, because why you're putting stopper? So that beyond that capacity of the bottle, there should not be any water. So you put stopper at the top and then you allowed it to dry down. And then you measure it mass, you do any physical calculation. So excess water or excess liquid, if it have, so it will drain out from it. So this ensures that the bottle contain always the fixed volume of any liquid filled into that. And this is we used to measure the density of the liquid. These all are self-explanatory. This is the formula which I told you. Here M2 minus M1 is the mass of liquid. M3 minus M1 is the mass of M2 minus M1 is mass of water. Okay, and M3 minus M1 is basically the mass of any liquid. When you divide them, you will get the relative density.
Okay, sir.
Similarly, if I talk about how you can measure the density of a gases, so very simple. To measure the density of gas, you take any measuring cylinder or flash. You measure. You know the volume. Always you know the volume. Whichever beaker or bottle you are using for the calculation of density of either liquid or either gas, you know the volume. If you don't know the volume, you can take the beaker of substance of a known volume, 25 ml beaker or 50 ml beaker or 100 ml beaker. You can take a beaker. Okay, you clean it properly, drain it, make sure that it get dried down. Make sure you clean it with distilled water. Then you can use vacuum cleaner to make sure, or vacuum pump to remove all the water from it. And then whichever gas you want to measure its density, you fill with that gas. So if you fill it with that gas, you can easily find the difference in mass, of the beaker, which we call as M2 minus M1. And if you divide this with the volume of the beaker, because volume beaker, why? Because the gas will take all the space of the beaker, correct, right? So that is what we studied in the property of gas, and that will give you the density of the gas. That is M2 minus M1 divided by the volume. Can you understand this part? Same formula what we use for liquid, the same formula we'll take for gas. So we take any bottle, any density bottle, or we take any beaker, we take any conical flash, we take any instrument, we clean it properly. Okay, we dried it down. Then we measured the mass of the empty beaker. Let that is M1. Then we'll fill it with the gas of which volume we want to measure. Okay, which volume to anyway we know, because we have taken a beaker of a defined volume. So now we can calculate it mass. So now we'll calculate it mass. So once we calculated mass, now definitely we'll see an increase in mass of the beaker. That increase in mass is because of the gas which you have filled into the beaker. So automatically you'll get the mass of the gas as M2 minus M1. If you divide it by the volume, you'll get the density of the gas. Is this clear?
Yes, sir.
So this much we'll do today. So basically in this chapter, what we are studying in this chapter, we are only calculating the densities of solid. We talked about density of liquid. We talked about density of gases. So all this we have done in this class. So any doubt, anything?
No, sir.
So I hope you understood what all we did.
Yeah, so then I had another one. Sir, is there any homework pending from my side? No.
I let you know. Let me see that part. I'll tell you.
Okay, sir. Bye, sir.
Okay, bye.
Sir.
Can I leave?
Yeah, you can leave. Thank you, Tanish. I'll see you next class.
Yes, sir. Tomorrow, sir, it will be on Monday, right?
Yeah.
Yeah, okay, so bye, sir.
Bye.